Okay, so here we are on the first section on Chapter 7, Applications of Forces. So you could have a title, Applications of Forces. And we're first of all looking at static particles. So here, the diagram shows a particle in equilibrium under the forces shown. By resolving horizontally, find the magnitudes of the forces P and Q. Now this really is revision of AS work without anything too tricky in it. It tells us what to do. The key thing is, if something is in equilibrium, what's that telling us? If it's in equilibrium, the resultant force in any direction is equal to 0. Yeah, if it's in static or dynamic equilibrium, it doesn't make any difference. Yeah, there is no acceleration, so the resultant force in any direction will be naught. And you're free to pick the directions that you operate in. So there's more than one way of doing this question. But they've asked us to do it in a particular way. So the first thing we're going to do is resolve horizontally. Taking to the right as 0, so that's from the question. It's what we've been asked to do. Yeah, resolving horizontally. And what are we going to get? Well, we know that the first thing that we have to do at that point, go on, David, what would that be? Yeah, you're right. Break down the forces into their components. So, horizontally, we get P cos, because it's adjacent to the angle. And on the other side, we've got 4 cos of 45 because it's adjacent to the angle. Vertically, we've got P sine 45. P sine of 45, not much space there, sorry, and 4 sine of 45 vertically there. But for the first part here, we're working horizontally, so we've got P cos 30 minus 4 cos 45 equals 0, since it's in equilibrium. The resultant force must add up to 0. So now we can solve that. P equals 4 cos of 45 over cos of 30. Cos 45 we should know is root 2 over 2. Cos of 30 we should know is root 3 over 2. So we can sort that out. We've got 2 root 2, 4 root 2 over 4 root 2 over root 3 newtons, which we could tap in the calculator. It should be roughly, what did we say, 4 root 2 over root 3, so 1.7, that's going to come out to be about 3.3ish, 3.2ish, something around that. Okay, you can check the detail on the calculator. Vertically, resolve vertically. Yeah, and again we've been told what to do in the question here, but we should have known that anyway, even if it hadn't been mentioned. So we're going to resolve vertically. And we need to go back to our diagram to look at that. So we've got vertically P sine 45. P sine 45 plus 4 sine 45 plus 4 sine 45 minus Q equals 0. Since equilibrium again, which we're told in the question. So Q equals P sine of 45 plus 4 sine 45. I've got something wrong there, haven't I? That should up there have been 30, sorry. Yeah, that should have been 30. Let's see if we can write that a little bit more clearly. Yeah, so that should be P sine of 30. So down here I should have had P sine of 30. So P sine of 30 plus 4 sine 45. Okay, that looks slightly better now. So P we've got as 4 root 2 over root 3. Sine of 30 we know is a half, plus 4 times sine of 45, which is root 2 over 2. You can tap it in the calculator at that point, and we get 2 root 2 over root 3 plus 2 root 2. So that's going to come out to be approximately, what would we get for Q? Roughly 4.5-ish, I reckon. So you can chuck that in a calculator and check the detail. There is a second method for approaching that question. And the second method, which is quite useful in some exam style questions. So method 2 is a trig kind of method. So if we've got 3 forces, I think it's 3 forces, P, Q, and the one we know, the 4 Newton ones, if they add up to 0, if forces add to 0, when we join the forces nose to tail, yeah, one plus the next, what must happen with that diagram? Have a think. What must happen with the diagram if we add the 3 forces together, one plus the next, and the outcome of adding those 3 forces is 0? Okay, well, let's see. If we draw it first of all, let's put on the one we know, which is 4 newtons at an angle of 45 degrees. We know that Q goes straight down from there. And now if we add on P, we must go back to where we started. So that angle there is 30 degrees. And once we've got the diagram, we are into a familiar, I hope, situation. Because you've got a triangle and we've actually know all the angles from the information we've been given. Because if this is 45 here, then that is also 45 because this was vertical. So that angle up there must be 45. That's 30. This is vertical. That must be 60. And that bit in there is also 35. So we've got a non-right angled triangle, not right angled triangle. What do we know? We know an angle and its opposite side. Therefore, what are we going to use? Yeah, you've got it, Connor? I hope anyway. The sine rule. And what are we going to be working out? We've been asked to find P and Q. Well, that's the magnitude, so we want the lengths of sides. So the version of the sine rule we use is the one with the length on the top. So A over sine A is equal to B over sine B. Okay, and now we just choose which we're going to find first. We've got the choice, P or Q. So if we choose to work out P first, say, we're going to have P over sine of 45 is equal to 4 over sine of 60. So P equals 4 sine 45 over sine of 60. Sine 45 is root 2 over 2, so that gives 2 root 2. Sine of 60 is root 3 over 2, so we get 4 over 4 root 2 over root 3, just like we did last time. Okay, and similarly for Q, we get Q over sine of 45 and 30 is 75, sine of 75, which is equal to 4 over sine 60. So Q equals 4 over sine 60 times sine of 75, and tap that in the calculator, and hopefully, if we've got it right, you'll get the same value, roughly 4.5 as we got last time. Okay, but just check. And that is the end of example 1.